Hello, scientists. Mr. Miller again, continuing our discussion of the water cycle. And if you remember from yesterday, we were talking about that we are going to be able to understand where drinking water comes from, what recycling our drinking water means, and what are some of the problems with our drinking water and why is it limited. So today we're going to continue our discussion. If you remember, we started talking about things like evaporation, liquid turning into a gas, and water evaporating off the surface of the earth or the oceans or lakes and streams and ground, and it goes up as a gas, condenses, becomes clouds, and as the clouds condense, lose energy, the water particles, the water molecules come together and start to grow. As you add more molecules, they get bigger and bigger, and ultimately gravity is going to knock that down and pull it down to Earth in the form of precipitation. Now, we said that precipitation has two pathways, and so that means it either is going to fall to the earth and it's either going to go into the oceans or it's going to hit the land. And that water vapor, since it equally wants to spread out, is in the atmosphere all around the world. So every place on the earth has precipitation from time to time. If it falls in the Arctic, in the North or South Pole, it is so cold that it falls as snow, and as the snow accumulates, as it gets thicker, the weight squeezes it down and turns it into ice. And those permanent flows of ice we call glaciers. We also see glaciers on the land, and we'll talk about those. But we said about 2% of all the drinking water is either in the ground or frozen in our glaciers. So we don't have access to it. So that's a big limiting factor. The other limiting factor is most of the water on the earth is salt water, and salt water cannot be consumed by living things. So if the water falls on land, we know that water, because we've all spilled a cup of water or a cup of milk or something, what happens to the water once it's released? Well, it's always going to flow downhill. So even if I dump it on the table, it's going to run along the table and fall to the ground. And then it's going to pool up. If the floor is uneven, it'll start running across the floor because it's always looking for the lowest spot. And that's because of gravity. The same reason why the precipitation comes down from the sky to the earth is that gravity's pulling it. Most of the precipitation, we said, falls in the ocean. And if it falls in the ocean, that helps to decrease the salinity of the water. And then I have lots of currents, and I have winds that create waves. And so the ocean is constantly moving, it's swirling, and it's constantly mixing. So any water that falls in the ocean becomes immediately undrinkable. If it falls on land, then we have something called surface runoff. And there's two pathways that water will find. The first is it may find ground or soil that is loose enough and dry enough that the water will actually go into the soil, and the soil will store some of that water. Most times, if it's on a side hill or on the side of a mountain, we don't get a lot of that, what we call infiltration or percolation, the water moving into the soil, so the water skims along the surface. And it's going to flow downhill in things called streams, rivers. It's going to accumulate in ponds and lakes. And eventually, as that water flow gets bigger and bigger, it starts out very small, gets bigger and bigger until it becomes big, large rivers. And if you've ever traced the path of a river, you'll note that all rivers eventually dump into the ocean. So all that water that's flowing in those rivers and streams, most of the time, because it's moving so fast, it's past us, we're not utilizing. And there's other problems with that surface water too. So here is another picture, and this is a little better. And it shows I have a valley between two mountain ranges. And if I think about the area over here on the other side of this mountain, there may be another valley over there. And there may be another valley up over here on the left. And all the water that flows, especially on these side hills, on the mountains, which are mainly made of rock, and rock doesn't take up a lot of water. Rock can because it has lots of cracks or holes in it. But just typically, if you dump water on a rock, you'll just watch it flow off. So all this water starts uphill, up here at the top, and it all wants to go to the lowest space or lowest place it can find. So it starts collecting with other water, and we said water is sticky, so water likes to stick with other water, and it starts to flow. And as it gets more and more of these inlets of water coming off the side, it gets bigger, deeper, faster. And if you notice, it kind of meanders around down here. And a lot of this runoff, this surface runoff, causes lots of erosion and actually digs this canyon deeper and deeper and deeper. So most of our rivers are getting deeper and they're cutting into the earth. And so some of like the Columbia River, if you ever look at the Columbia River, it's carving, it's a big river, and it dumps directly into the ocean down in Astoria, Oregon, and right there between Oregon-Washington border. Okay. So as this flows, it gets better, bigger and bigger, faster and faster, more water. So if we think back for just a second, so surface water or surface runoff is just water that stays on the surface. For some reason, it doesn't go into the ground. It just flows along the top and runs downhill to the lowest point. And we all know that the lowest point on Earth are our oceans because that's where all the water is. And gravity forces all that water into the oceans. So if we look, I had you define the word watershed. And a watershed just describes the pathway that water takes once it's released onto the land surface. Okay, so this is what happens to water precipitation when it falls on land. And so here I have a cloud. The cloud is precipitating. That means it's falling rain. Up in the top of the mountain, it may be actually putting out snow. So the snow is piling up, and we call that the snowpack. During the summer, a lot of this snowpack melts to continue to add water to our watershed. And so if I start up in the mountains, I might have water running off all of these surfaces coming in different ways through the lowest parts of the ground. And all these little things called tributaries, we call them streams, we call them brooks, we call them creeks, but they're small bodies of water, and they're going to keep going. And since they're going to the lowest point, typically they're going to meet other tributaries. Creeks are going to meet other creeks. They start getting bigger and bigger as these things come together, and there may be thousands of creeks feeding a river, and a river is not a river until it's a certain size. It's a creek or a brook. And then some of this water gets trapped into low areas and forms what we call lakes and ponds. And as it flows, it's constantly taking whatever it flows upon. So that means any kind of life, plants, sediments, soil particles, all of that is being washed down. So now all this fresh water is mixing with all of these natural contaminants. And if you notice, this just shows a long valley. And as this goes, it gets bigger and bigger. And I might have other rivers coming together. So this might be the Columbia River. And you should know that the Snake River, which comes from Oregon and Idaho, dumps into the Columbia River, and that actually flows and makes the river bigger. So as you go down closer towards Portland, the river gets bigger and bigger compared to what we see up here, up in Washington by Moses Lake. So all of this water, that anything that doesn't go into the ground stays on the surface and flows to the lowest point. Now, what is another problem with our fresh water? Well, originally, people, when they settled new ground, wanted to be next to water because water is life. You may have a garden, you may have animals, you have to bathe, you have to cook, you have to drink water yourself. So most places where people lived were next to water. And because people lived next to water and we didn't know any better, a lot of times they were bathing, washing, allowing their animals in the water, so that if you lived in a town and there was a town up above you, well, they may be dumping all kinds of waste that you're not aware of, and now you're down here bathing and drinking that water. And as we learned, our practices were contaminating the water, making it unhealthy for us to drink. And all of our big major cities, if you think about it, are located on waterways. They generate waste. They have to get rid of it. And early days of man, all of that would go in the river because it would wash down. It's out of sight, out of mind. Hey, no problem. And we also have lots of agriculture because we need water to grow plants, to grow fiber, to grow all the things to feed the animals so that we have all the food that we need. We have forested areas that we mismanaged or cut down and allowed more surface erosion, which caused more sediments, more pollution. Agriculture uses chemicals. We use fertilizers. But the problem was agriculture got blamed for all the stuff that was ending up down here at the end of the river that was pouring into the ocean. And when we looked into it, we found out that 2/3 of all the pollution is coming from the towns, coming from people living in cities, because they fertilize their yard, they spray pesticides, they kill bugs, they kill mice, they do all that kind of stuff. Okay. And then down here I have factories, and factories located next to water because they needed water for power generation. They need water for processing, for cooling, for all kinds of things, because everything we produce in the United States, from steel to plastic, requires the use of water in some shape or form. Okay. And then down here, they talk about percolation, and percolation and infiltration just talks about some of this water. Eventually, if it's on the surface long enough, we'll find some way to get into the ground. And under the ground, this water is flowing in like rivers and lakes underground, which we call groundwater. And the problem with groundwater, and you can see it here, if that didn't keep coming up, but it's called an aquifer. And we are pumping more water out of the aquifer, and the aquifer can't recharge because of percolation and infiltration of water to recharge the groundwater. So eventually, we're going to run out of groundwater in lots of areas because we're drawing way too much out. And it's all because of, if you think about the consumable water, all this water that's flowing across the earth, if we're going to drink it, we have to process it. We have to purify it, and we have to filter it. And that will make it drinking water. But some of it is pretty bad. And it really was bad in the early 1900s until we found out what we were doing. And in the last 50 years, the EPA has put very stringent laws on everybody, from agriculture to forestry to industry, even to homeowners. So if you want to build a factory, you want to build an apartment, you want to build a house, you have to file an environmental impact statement to show that you are not going to negatively affect any flowing surface water, groundwater, or any of the ground around you. And that was a good thing. And we've cleaned up 90% of the pollution that used to be in our rivers and streams. But some people don't think that's enough. I think it's great because now we are aware we're not doing the things we used to do that caused the problem. And hopefully, as we get smarter, we'll come up with a solution for the problem. All right, so, what I want you to do in your science journal today is to think about what we talked, replay the video if you need to. I want you to define surface runoff. So what is surface runoff all about? Why does surface runoff occur? What are the two major pathways that water can travel? And I'll tell you, it's either percolation or surface runoff, right? Flow. And then I want you to explain what a watershed is and why it is so important to all of us humans and why it helps to recycle or bring the water back to the ocean so it can evaporate again and become pure water. All right. See you guys.